Hello, Mr.BulBul. This is my math project on the three trigonometric values of a right angle triangle. The theta, which is basically the angle of the triangle, it represents the angle, and you can see that right here. The hypotenuse is basically the longest side of the triangle, and the opposite, or the theta that's basically opposite of that side, is the opposite side, and the side next to the opposite side is also known as the adjacent. So we distinguish all these three sides with these letters, and we are given these three trigonometric ratios, which are known as sine, tan, and cos. And you can see right here how I listed it, and it basically gives us what the ratio should be. So for example, tan theta, right? This is where you would put in the angle. Basically, you would use opposite over adjacent. So, and we can see this here with this example right here. Opposite we have is our 2, and our adjacent is 4, so it'd be 2 over 4. And then if you simplify that, you can get 1 over 2, and then the decimal value would be 0.5. And also here, cos adjacent over hypotenuse. You can see right here the a and h is here, 6, and sine opposite over hypotenuse. The o is here and the h is here, and we basically just put these values in to give us the missing side we're looking for. As I already showed you with cos, but we can also show you with sin. 2 over 6. Opposite is directly looking at over here, which is this our opposite side, and then there's number 2, and there's also 6, which is our hypotenuse, the longest side of the triangle, which is 6 right there, and you're left with 2 over 6. You can simplify this to 1 over 3 and gives you the decimal value of 0.33. And lastly, tan, we could, cos, you could see, which is 4 over 6. Cos is, as we look here again, adjacent over hypotenuse. So then we put in the 4 and the 6, and that will give you 2 over 3, and the decimal value is 0.67. Moving along to our example question on how to use this trigonometric ratios to help find the height of a tower. Well, a man is looking at a tower at an angle of 32 degrees. The horizontal distance between you and the tower is 250 meters. Find the height. So we already know that this man is looking at the tower, the top of the tower, at an angle of 32 degrees, which is an angle of elevation. As you can see, this is our little man right here. And we also have the information that it's 250 meters, like a horizontal distance between him and the building. So that's basically on the ground. So if the man was looking at the building from the ground, like at the bottom of this would be the horizontal distance from it. So which is given here 250 meters. And we're trying to look for the height, which is our opposite, or y to say exact. And we can do this by actually using our angle and our horizontal distance. So as I wrote it here, I used tan theta because we're actually trying to find the opposite side. So we got o over a, so we just put it in. This here, which is our theta, is our angle, so we write 32 degrees. And we also have y, which is our missing length that we're trying to find, and 250, which is the distance between the man and the building. And if we just do cross multiplication, so you could see it as like this, it would be, you could think of it like this, which is a 1, and you just do cross multiplication, so it'd just be y, and then tan 32 times 250, and tan 32 is just 0.6248, and then you times that together, which give you 156.26. So this would actually be equal to y here, and this is the missing, this is the height of the tower. Over here we have two triangles that are like distinct and look the same, but we use two different ratios to actually find the length. Example, over here we use sin, so the triangle hypotenuse over here is 190, and we're trying to find the opposite side. So we use x to represent our O and 190 to represent our h. As we remember back on the original page where we wrote our ratio is opposite and hypotenuse for sin, so O over h, and we've done that exactly here. And then we would just times sin 53, which is the angle of the triangle, times 190, which is the length. And once we times that, we'll get 151.74 for x, which is the missing length we're trying to find. And this triangle also looks similar, but we're looking for our adjacent side this time, where we'll use cos 53 times 190. So we do cross multiply, and remember cos is adjacent over hypotenuse. So that means we use our adjacent, which is our x side, and 190. So it's also again really similar. They're distinct, but it will still give you a different answer. You have to always remember to use the right ratio for the right side of length. And what we got here was x equals to 114.34. So basically this answer here, 151.74, is your opposite side of the triangle, and this is your adjacent side of the triangle. And lastly, right here, we use two triangles that look the same to find the angle of the theta, which is basically that little like zero with the line right there. Over here, we use sin theta because we have the opposite and hypotenuse lengths. So we have to do the inverse when finding the angle. So you on your calculator, you do sin and it has like a -1, and then bracket, and you just put in the value. So it's similar but not exact. But example here, sin, remember opposite over hypotenuse, our O is 17 and our H is 32. So we got 17 over 32, which gives us a value of 32.0899. And once you've done that, you have to round it to the nearest angle or nearest whole number, and which our nearest whole number is 32. So it'd be 30. So the missing angle is 32 degrees. For tan theta, we have the values 17 and 24, so we have our opposite and adjacent, but this time we have to use tan, as tan is opposite over adjacent. And I remember the -1, so we do tan -1 bracket 17 over 24, and once we do that, we get a number of 35.3112. And remember to round it to the whole number, and you're left with 35 degrees. So the angle of this right angle triangle is 35 degrees, while this one is 32 degrees. Thank you for watching.